Now we'll take a look at Euclid's algorithm for finding the greatest common divisor of two integers a and b. We'll consider them both positive now, natural numbers. Now it could be that a and b are so large that you do not have time to write down all of the factors of a and all of the factors of b and find out which their largest common divisor is. So this algorithm is going to be repetitive. We start off by using what we call the division algorithm. We've seen that. We take these a and b and we write a equals qb plus r. I labeled them q1 and r1 because as we iterate, we're going to have a q2 and an r2 and a q3 and an r3 and so on. But we've used the division algorithm, so a is q1b plus the remainder, and as we know, the remainder will be less than b, greater than or equal to 0. Well, if it turns out that r1 is 0, there is no remainder, well then we're done. The greatest common divisor of a and b would simply be b. If that remainder is 0, that means b goes evenly into a. All right, so otherwise, we'd have this case. The remainder is greater than 0, and we're just going to repeat the process. Only the difference is going to be our new a and b are the old b and r1. We're going to take those two numbers. That's going to be my new a and b. So it comes down to this. Instead of a equals qb plus r, we have b is q2, our new quotient, and that r1 came down here, and we're going to get a new remainder, r2. And this time, r2 is less than r1, and it's greater than or equal to 0. So we just did the division algorithm again. Once again, instead of using a and b, the second time through, we're going to use b as our new value of a, b equals, and instead of b being here, we're going to drop down this r1. Do the same thing. All right, so once again, if this r2 is a 0, we're done. Okay, that means that r1 divides evenly into b, and r1 would be the greatest common divisor of a and b. If not, we're going to do this again. So this time our new a and b are going to be r1 and r2. So we say that r1 is equal to some new quotient times r2 plus a remainder that we'll call r3. And r3 is in between 0 and r2. Strictly less than r2, greater than or equal to 0. If r3 happens to be a 0, then we're done. And we proceed, we continue until we get a remainder of 0. So notice that in this comment, these remainders are non-negative and they're decreasing. Notice what we have here. R2 is less than R1. R3 is less than R2. R4 will be less than R3, and so on. So we're decreasing, and we're positive, so eventually we're going to equal 0. So the Ri's are non-negative and decreasing, so eventually some Ri is going to be equal to 0, and we'll be done with the process. So we consider the final two iterations. This one says that Rn minus 2 is equal to Qn Rn minus 1 plus a new remainder Rn. All right, well that's the second to the last one. Then we finally get Rn minus 1 is equal to a quotient times Rn plus a 0 remainder. That means that we're done. And finally, the last non-zero remainder, which I'm going to go ahead and circle and maybe put an arrow up there. is the greatest common divisor of A and B. Now, I know that may have been a little harder to follow. It's actually easier to use examples and use Euclid's algorithm, and that's where you can really form the habit. You can figure out exactly how it's done. So we will do that in the next video.